Hello, everyone, and welcome to today's Tech Talk on commissioning terminal units. Stop testing them wrong. My name is Sherry Adams, and I'll be the moderator for today's session. Please note that throughout this Tech Talk, all the phone lines will be muted, and this will minimize any background noise or feedback that could distract from the presentation. We will use the Q&A function, so when you have a question, please submit it through the Q&A box. We will also be gathering these questions throughout the Tech Talk, and we'll leave time at the end for Q&A. If you have a question related to a particular slide, please include the number of that slide in your presentation. A PDF of the slides from this presentation will be sent out electronically to all those who have attended today, and we'll also be recording this Tech Talk, and it will be available on our website under the resource section. Today's Tech Talk is brought to you by the Texas chapter, and today's presenter is Thomas Cocker. Thomas is currently the tab director at Page Sutherland Page. He has been in the industry for over a decade and has worked in test and balance, commissioning, and mechanical design. So welcome, Thomas.
Thank you. Thanks for having me. Oh, I'm going to get started? Okay.
Sorry, you bet. Thanks for being here.
Yeah. So how's it going, everyone? And really, this is to go over terminal units, and I know a lot of people, this is kind of basic, but I just thought that, you know, I could help some people save time in the future when testing these units, since they take up the majority of our jobs, and just try and find some efficiencies. So what is a terminal unit? It's a box. I don't want this to be too entry level, otherwise I know a lot of people will probably get bored. So keep in mind, some of these techniques are not really worth modifying your test scripts. I would keep the test scripts the same, but it may require you to skip around. So first up is sampling. I always like to talk about this with each type of equipment because the method for sampling, or even if you should do it, changes based on the equipment type. So for terminal units, I'm an advocate for sampling. It helps you to be more competitive on bids. You're testing a canned program, and if you find one mistake, it usually applies to the rest. But if you sample units the normal way, it can actually take longer for the controls contractor to command a sample of units versus all units on a system. For example, if you cherry pick about 20 units to sample, the controls contractor has to record which ones he's modifying and then select only those units and commanding them as needed, or he can just command them all. I'm sure you guys and girls have seen these screens before, and I suggest asking if these summary screens will be created for your project ahead of time. Most controls contractors these days will go ahead and program global commands and terminal unit summaries, but it never hurts to ask at the beginning of the project for the features. It will make life easier for not only the commissioning provider, but also the test and balance contractor. So if you want to take a sampling approach, utilizing screens like this can tell you right away what boxes should become part of the sample. If you don't sample, these screens can also help alert you to problem boxes before you get to them. Let's quickly go through a few noticeable issues on this screen, and I'll give you all a second just to scan it. So let's assume the first row is box 1. We can probably assume boxes 1 through 4 are still modulating to set point, but what's going on with box 5? This could be a communication issue. What's going on with box 7? 16% damper position and still above set point. If this box is not at the beginning of the run, there may be a calibration issue, or maybe the box is oversized. All other terminal unit damper positions are considerably more open. And last but not least, number 19, the damper is 100% open, but no flow. Maybe the tubes to the flow cross were disconnected. Maybe the T-caps have degraded and fallen off. Maybe there's a zeroing problem. Maybe the transducer is bad. So before we tested or commanded anything, we may have already discovered 3 issues. I feel like this is how contractors view us when we're on site. So how should testing start? This is obviously the CXP's preference, but we feel like starting with safeties and alarms, is best, usually because it verifies that any full capacity testing will not hurt the system. Now, for most terminal unit safeties do not apply, but nevertheless, it's a good habit to have. Testing space temp alarms. If the building is occupied, and this may be obvious, but do not try to cool or heat the space to trip the alarm. People will get uncomfortable. Instead, try adjusting all high temp alarm set points below the current temp reading and adjust all low temp alarm set points above the current temperature reading. Also consider changing the alarm time delays for the purpose of testing, then putting them back to their original value. If there are discharge temperature alarms on the terminal unit, suggest having the engineer or owner remove them. They're useless, unless it's a high limit cutout for an electric reheat coil, but that is different than a high discharge air temperature alarm anyways. For fan failures, if they're applicable, they're fairly simple. Usually you can override all the fan statuses at one time to be opposite of the command. If you don't feel comfortable with that, you can go to each one in the sample and remove the CT on the fan. So just in case you're wondering how you can record all of the answers to all of the boxes at one time, make sure you're using the right technology for the job. So this is an example of FacilityGrid's batch functional test complete screen. If you click the answer choice on the left, the leftmost box, it will automatically fill out all of the boxes in your sample. So what's also great about this is if you have a similar comment for multiple issues, it allows you to copy the comment to all boxes so you stay consistent. Also, you can create all your issues on this screen and never navigate away while testing. So can we be more efficient than just testing the alarms at one time? Why not test max cooling while testing the high space temp alarms? All the high alarms will be tripped at the same time, and you can quickly click through the sample of boxes to verify the alarms appear on the graphics. Placing all the boxes in full cooling at one time will help to be more efficient, but it will also help to check for tab issues. For example, this image shows series fan-powered terminal units with the space temperature overridden to 80 degrees to drive all boxes to full cooling. Once everything has settled out, review the list for issues. And let's look at a couple. So looking at FPTU 3A 5, 6, 10, and 13, the damper is 100% open and cannot meet flow set point. If the AHU is maintaining its static pressure set point and there is no diversity in the system, then the static pressure set point is not correct. So look at FPTU 3A number 4. Discharge temperature or supply air temperature is too high. The AHU is delivering 55 degrees, yet the terminal unit is delivering 64 degrees. Either the box has lost its calibration or was never properly neutralized by tab in the first place. This will obviously create cooling issues in the future. So what is neutralizing? Let's go down a quick rabbit hole. Neutralizing is when balancers will adjust the fan speed on the series fan powered box until the primary error matches the fan output. After the box has been calibrated and proportioned in max cooling, the balancer will replace the filter with the meticulously calibrated and extremely expensive device you see on the right. Some may call it scrap cardboard and tissue paper. The fan speed is then adjusted until the tissue paper stays vertical. This proves that no air is entering or leaving from the return during max cooling. If you ever see filters that bow out away from the box, or if you put your hand to the filter and feel air coming out of the box, there is an issue. Air should never blow out of the filter in any mode. In really bad cases, I've actually stuck my head above ceiling in the summer and it was colder above ceiling than in the space. That usually means the entire building will need to be rebalanced. And as a quick note, neutralizing does not need to be done on boxes without a fan or parallel boxes. Parallel box fan speed is adjusted during heating mode to the scheduled or submitted fan CFM. Since you've already driven the system into full cooling, at this point, you might as well check the static pressure set point. This may require some further manipulation if there is diversity, but the system should still settle out faster if it is done now rather than later when testing the AHU. A few things to be wary of in this step. If you see the static pressure set point at 1.0, 1.5, or 2.0, it was probably never set by test and balance. Generally, 1.0 and 1.5 are generic set points listed in the sequence of operation and are not intended to be the final set point. So the set point can end up being 1.0 or 1.5, but it is rare. Another thing to look at is the static pressure reset range, if applicable. The max set point on the static pressure range should be the same as the one in the tab report. The static should never need to go above that value. The minimum set point can be 0. It doesn't really matter because if the static pressure reset is programmed correctly, it will reference all terminal unit damper positions, and if any go below 95%, it will stop resetting down. Also, the minimum speed setting on the VFD drive will prevent any issues with the fan motor. So to set up your system to check the static pressure set point, total the box max cooling set points and make sure it is equal to the AHU CFM. Keep in mind you are commanding the terminal units to max cooling airflow set point. You are not commanding the damper to 100% position. That is something different. You really should never command the terminal unit damper unless you are troubleshooting or verifying the damper span. You should never see the sequence saying the BAS should modulate the terminal unit dampers to 100% open. That should never happen. You should always, always, always allow the terminal unit to control to flow set point. This should also be the case for outside airflow, but that is another topic in itself. Anyways, at this point, the AHU should be at its static pressure set point and all the terminal units at their max cooling set point. Now look for the worst case damper, meaning the terminal unit's damper that is the most open. This damper should be no more than 90% open and no less than 80% open. If you see any dampers that are 100% open, there is an issue with the static pressure set point and it may need to be higher. If you see all dampers below 80% open, there is an issue and the static pressure may need to be lower. Now, if there is diversity, there are a few ways to take that into account, but I'm going to tell you the way I like to do it. For those of you that don't know, diversity is when the terminal unit max cooling CFM is higher than the design CFM of the AHU. The engineer anticipates that the building will never see full design flow, usually because people will not fully occupy the AHU's associated spaces. So the process for determining static pressure set point on a unit with diversity starts out with the same as if it doesn't have diversity. Command all boxes to full cooling, but then start commanding the boxes closest to the unit to minimum flow or heating mode until the box total adds up to the AHU total. I don't like to shut dampers because I always want all my boxes controlling and modulating during the step so I can see if there are any PID loop issues. Do not command the boxes furthest away from the AHU to minimum because they are likely to be your worst case dampers. I have them marked out in the picture. Once the system settles out and the AHU is at static pressure set point, look for your worst case damper position. Again, the same requirements apply. If your AHU does not reach static pressure set point, you'll have to look for restrictions on the inlet to the AHU on the outlet prior to the 2/3 sensor or possibly speeding up the fan either at the drive or shiv. Either way, it is not normal for the AHU to not be able to reach set point regardless of the mode of operation. If you find that one box has issues getting its air, it may not be worth bumping the static on the AHU just for one box, especially if you have to add 1/4 or 1/2 inch to your set point. At that point, you may want to check the inlet conditions to that box, see if the correction factor on the box makes sense, see if the max cooling design CFM will mean flowing over 2,000 feet per minute through the box inlet. The box may need to be increased in size. Ideally, some of these issues would have been caught during the design phase or during a site observation. Setting the static pressure set point with a Phoenix valve or similar. If test and balance says they cannot set static pressure set point on an AHU that serves lab valves, you can call BS. Every Phoenix valve, whether serving the supplier exhaust, will come with differential pressure ports to verify the valve is within its pressure range to control flow. Tab will need to read each one, or at least the units at the end of the run, and lower the static at the AHU until the differential pressure across the valve is just above its minimum. Obviously, you will want to put a buffer in there to avoid nuisance flow alarms. A good balance company would request a trend on that flow alarm for at least a week to verify the set point is correct. And just as a side note, Phoenix actually sells static pressure reset kits for the valves, which is basically a differential pressure sensor installed on each valve. I think the valves should just come with them in this day and age, but if you can get away with charging extra, why not? And that information is really for design reviews. If you see those Phoenix or submittal reviews, if you see those Phoenix valves submitted without those static pressure reset kits, and you're supposed to have static pressure reset in your sequence, it's worth making a note. Heating mode. When we test the other extreme, all low alarms will be tripped at the same time, and you can quickly click through the sample of boxes to verify the alarms appear on the graphics. So believe it or not, this is an image of a settled system. Obviously, there were a lot of issues. This one happened to have an overactive PID loop on top of that. Controls programmed an unnecessary safety into the box to not allow the electric reheat to stage when the primary error was too low. You know, that's not needed, especially if you want to heat the space in unoccupied mode without the AHU engaging. In this mode, you can also check capacities on the reheat coil. If you have a standard VAV without a fan, you know the air temperature entering the heating coil is roughly 55 degrees or whatever the AHU is sending out. If you have a series fan power terminal unit, you will have to calculate the entering temperature to the reheat coil. This will tell you your temperature differential across the heating coil, and from there you can calculate capacity with a sensible heat equation. You also have the ability to compare all of the terminal units together to see if one is lagging behind. It's good to do this with all types of reheat, but especially for hot water. It can help you discover coils that are clogged, isolation valves are closed, or possibly coils that are piped backwards. Whichever temperatures you see lower than the others are worth adding to your sample to visit in person. So with this slide, we're going to go over a little bit of the sensible heat equations and how to calculate mixed air temperature. And if you want to figure out the temperature entering the reheat coil on a series box, you can use this equation. And honestly, both these equations should be memorized. To figure out return air temp for this calculation, I usually use space temperature for mild days or 5 degrees higher than space temperature for hotter days. You can also just measure it and assume it's roughly the same with all associated terminal units. Again, these are rough calcs to check coil performance for issues. And sometimes you don't even have to do the calc, because you can tell if all discharge temperatures are between 85 and 90 degrees, and if one is at 65 degrees, there is a problem. But I like to get a ballpark value to help me with this step. So before getting out of heating, let's look at the associated AHU's outside airflow versus its set point. We can also look at its damper position. When all terminal units are driven to heat, the AHU will operate at its lowest speed, which is when, and again, this is mainly for warmer climates. And so when it operates at its lowest speed, it is the hardest to get its design outside air. This is the best time to check this value. Sometimes the terminal unit's heating CFM will add up to less than the total outside air of the AHU. Ideally, this is caught in the design phase, but it's never too late to catch an issue. Outside air should always be controlled to its ASHRAE 62.1 minimum set point, unless you have CO2 sensors in the space or a combination of CO2 sensors and occupancy sensors. Now, if the active outside air set point is lower than its max, override the active set point to its max value, which should be the same as ASHRAE minimum, unless increased for building pressurization. You can also artificially increase the CO2 in the space to drive the outside air set point to max. If the AHU cannot maintain its max set point, there is a problem. This is one of the main reasons I see pressure issues in buildings. Everyone checks the unit in the max, but forgets the minimum. If the unit cannot maintain max set point, how can we fix it? There are a few ways this is done, and some fixes happen to grind my gears, like modulating the return air damper inverse of the outside air damper. Don't do that. The best way to do it is to only start modulating the return air damper once the outside air damper is 100% open and cannot maintain its set point. Now, obviously, if you have a dedicated outside air unit that delivers outside air to the AHU, you will not need a return air damper, but it's still good time to make sure that the DOAS has enough power to deliver the outside air without much help from the AHU. Now we head to the dark side. For anything involving scheduling, I like to test it as few times as I can. So I usually get all the occupied mode testing done first, then test unoccupied at one time. If you think about it, why test the whole building in unoccupied, but only test part of the building at a time in unoccupied mode? Testing the whole building allows you to see how your building pressures will be during this time, and it will make it easy to see if anything was left off the schedule. For the functional tests, I don't like to put any questions in the terminal unit FPTs for unoccupied mode or optimal start. I usually place all those questions in the AHU FPT, but I will reference them in the terminal unit one. It's less questions to answer and easier for me to track. I started doing this before Facility Grid came out with their batch complete feature, but I still like the way it flows better than filling out this section in all the terminal unit functional tests. Optimal start. One fast way to test optimal start is just by looking at the trends. Sometimes in Texas, all you need is 1 week worth of trending and you will be able to see morning warm up and cool down. If you only get to see one, then you can manipulate the system either the day before to review the trends the following day, or you can just trick the system into optimal start right then and there, which is kind of hard to explain, but let's say we're on site now and we start with the building occupied. Then schedule it to unoccupied about 5 minutes from now, then to occupied again in about an hour from that time. Once the building goes unoccupied in 5 minutes time, we adjust the space temperatures to extremely hot or extremely cold, but still keeping them inside the night setback set points. We do not want to go into night setback. We want to go into optimal start. So let's say your night setback set point is 55 degrees and you want to override your space temps to 56 degrees. This should force the morning warm up to start almost immediately. Then just verify the outside air damper remains closed and the associated exhaust remains off. As a quick note, most of the time optimal start is not spelled out in the sequence of operation. Either the engineer leaves it off the sequence completely, so you'll have to reference ASHRAE or IECC to get it programmed, or they just say provide optimal start without saying how it should be programmed. Now, I don't know how many times I see morning warm up energize the AHU with a system of only fan power terminal units. You don't need the AHU for morning warm up if you have only fan power terminal boxes in your system. I also see the AHU energize in the occupied state during optimal start. Keep in mind, optimal start occurs before occupancy. You do not need outside air. So it's worth adding the comment in the design reviews to fully define optimal start to avoid a headache later. Like you can avoid the headache. Any questions?
Excuse me. Thank you, Thomas. Yes, we do have some questions that have come in. One was a little earlier on. It said, do VAV boxes need a minimum duct static to function? And should the low duct static set point of a reset be this minimum?
So yes, they can have a minimum inlet static, but usually I've not seen that become a problem in reset. So I would say no. they probably do not need to. But again, that would be worth trending just to verify if your job happens to be the one, random one that happens to have that problem. I haven't seen it on any of mine, but you're right, it could happen.
Okay. And then another one we have here is on the sensible heating equation, should the constant be 1.08 as opposed to 1.8?
Did I put 1 point? Okay, yes, you are correct. 1.08. I'll modify that. Yeah.
Good. Okay, at this point, there isn't any questions, but I have a couple quick announcements. So if anybody does have any other questions, now would be the time to ask. But just as a reminder, we have our annual conference that is coming up. It'll be a hybrid event, October 7th and 8th in Toronto. So look for some details on that on the website, hopefully by the end of the week, including the agenda. So we have that going on. And it doesn't, I don't see anything. Oh, wait, oh, yep, another question. Okay, let's see. If you are using global commands for sampling, how do you confirm that the point-to-point has been verified?
Good question. So again, that's part of the part. Well, that part you would want to do one at a time. And again, on your sample, the global commands is mainly to help you gain efficiency during full cooling, full heating, and not necessarily for the point-to-point checks.
Okay. And then we have another question. Any suggestions or tips for testing boxes for TI scope with owner-controlled AHU?
TI scope with owner-controlled AHU. So you're talking about a build-out job where you originally didn't test the AHU? Is that what you're saying? I'm a little confused at that.
Could we get any clarification on, or a little bit more information on that question? Maybe we'll give them a moment to see if you can expand.
So one thing I can think of, again, in occupied buildings, there may be further manipulations to the system that you may want to do. Some things that I've done before, and again, it's all dependent on what your outside air conditions are, but usually I'll reset to, if it's occupied, I'll reset the discharge of the AHU to a certain temperature just so that I know I'm not going to be making the people uncomfortable. So maybe I'll command it to 65 degrees and then I can get the boxes into full cooling for a longer amount of time. And again, that kind of affects how you'll be able to check the balance of it. But sometimes during an occupied building, you just know that you're going to be spending more time testing your units because of occupant comfort. So that's some of the things you can do. And again, on heating, it's a tough one. You'd have to do heating pretty quickly, just because you don't want to make anyone uncomfortable. But you could also reset your AHU to discharge lower so that, when your heat's on and full, you won't be heating the spaces up too much.
Okay.
Hopefully that answers your question.
Yeah, it doesn't look like we had a follow-up, so hopefully that did it well. But we do have a couple other questions that came in the meantime. How are you verifying sensor calibrations globally?
Sensor calibrations globally, again, so for terminal units, there's really no sensors to be verified other than the flow cross, right? And so on those, if you want to verify the flow cross, you would need tab to be there. There's no other way to do it. If you're going to verify the discharge air temperature sensor, you can do that globally because they all should be roughly the same in full cooling, right? If you're going to do thermostats, then on that one, there's no good way to do it. You pretty much have to go to each one separately. I mean, again, some things you just, there's no other way to do it than to go to each one.
Okay. And then it looks like our final question here is, do you typically go in and sample airflow sensor calibration with your own calibrated tab gear or ask for a sampled demo from the tab agent?
Oh, that one just depends. So ideally, you want the tab contractor to bring their own equipment, right? Because it's calibrated at their, wherever they sent it off to be calibrated, and your tools may be on one side of the scale and their tools are on the other side of the scale. You just never know. And if you have tight constraints, it's better if they bring their own tools. But if you have a stubborn tab contractor, which you run into every now and again, then you can bring your own tools just for, but just keep in mind that, again, your tools just need to read close. You won't get, I wouldn't put as much emphasis on staying right at that, plus or minus 5% if you're using your own tools, just because yours could be calibrated just a little bit higher than theirs or a little bit lower than theirs. Unless you run into, like you're doing a hospital with isolation rooms or something like that, and pressures are very, very important. At that point, I would start checking under doors and just making sure that you're maintaining, if like you read, I guess a +7 on one of your readings, then I would check under the door and make sure you're still maintaining your pressures in that room. And if you are, then it's probably okay. Because again, 2%, it's really not that big of a deal as long as you're maintaining that pressure in the room.
Okay, well, that brought in a few more questions now, so
Okay.
we'll see if we can't cover a few more. Can you elaborate on your comment about programming the outside air and return air damper positions? I believe you stated that the outside air damper should open to 100% before the return air damper begins to close, and the RA should not be inverse of the OA?
Right. So the way I approach that is from a balancer's perspective. One of the basic rules is you always keep one damper open, right? And so how many inlets do you have to an AHU? Well, typically 2. You have your return air and your outside air. And so if you're starting to close both those dampers, right, one goes inverse of the other, that means they're both closing at the same time, or they're both relatively closed at the same time. One's opening, one's closing, but they're still pinched off. Then you're restricting the inlet to your unit. Outside air is almost never sized the same as your return. Your return is always full flow. Outside air is like 30%. So you don't want to, you really don't want to do that. So ideally you want controls to just program it to where return stays open all the time. And then outside air will start modulating open. And if it gets to 100% and still cannot maintain its flow, then you pinch the return. And if you do it that way, you always keep one damper open. And that's the way I look at it.
Great. Okay, then it looks like our final question is, if ceiling wall sensors airtight is not covered in the spec, what strategies do you use to stress the importance of getting this done to the AEs so that wall air is not driving the TUs under negative pressure conditions?
Oh, I don't understand that one. It may not be a system that we encounter too much over here.
Okay.
I would send me an email on that one.
Okay.
I'm interested. Send me an email on that one.
That sounds good. We'll get that one taken care of offline. So, well, that is great. We really appreciate, Thomas, your time and expertise today. And on behalf of the BCA, I'd like to thank everyone for participating in today's Tech Talk, and have a great day.
Thank you.
Thank you.